Assumptions 1 and 2 are methodological and should have been addressed either before or during data collection. The other assumptions can be tested with the statistical package. In this case, we're using SPSS. Assumptions 3 and 5 are similar to the repeated measures ANOVA. However, when there's a between subjects factor, the additional assumptions of homogeneity of variance and homogeneity of covariance apply. Now, neither of these assumptions are critical when sample sizes are equal or close to equal.
So what we're looking at here is a mixed ANOVA or a mixed factorial ANOVA. So that's a combination of between subjects ANOVA and a within subjects ANOVA. So there's a between subjects measures and a within subjects measures. So let's just step through the data. So what we've got here is ID, which just allows us to identify the actual individual. And then we've got activity, the activity of abseiling, bowls, and meditation. And they're variables that each participant does. So each high school student does abseiling, each high school student does bowls, and each high school student does meditation. And then we've got some measure of personality, which in this case is a measure of introversion or extroversion. So let's just have a look at what these variables are in more detail. And this, you can see here that the personality is either a 2 or a 1. So this is the between subjects variable. It's a natural groups design for that personality. So let's have a look at the variable view. So we can see here that when we look at the labels, or the label for abseil, bowls, meditate, it's the same as the variable name, so it doesn't give us much information. And nor does personality. However, when we look at the values, we can see that extrovert is scored as 1 and introvert is scored as 2. So as I said before, that's a natural groups design variable. You know, the millions of moments that have made up you and the millions of moments that have made up me, we can't assign those people randomly, so that you're either an extrovert or you're an introvert, and so hence it's a natural groups design. Let's go OK and go back to data view. So if we have a look at participant 7, ID 7, this person, they abseiled, they got an enjoyment score of 26, they did lawn bowls, they got an enjoyment score of 16, and they meditated and they got an enjoyment score of 29. And now hopefully those activities have been counterbalanced appropriately to ensure that fatigue effects don't play out in those scores. And then we've got a score of personality of 1. So if we went back to there, we can see 1 are extroverts. So we can see that participant 7, ID 7, this person is an extrovert. So the first thing we want to do is evaluate some of the assumptions. Now, one of the assumptions are normality across the variables for each cell. So we're going to have to split. We're going to have to split personality into introverts and extroverts and look at those separately and check out for normality for each of the variables: abseiling, bowls, and meditation. And we want to also look for any univariate outliers in that space. So to do that, first thing I want to do is split my file. So data, split file, and I want to split it by my between subjects variable, which was personality. So compare groups by personality. So what that's essentially saying, so I'll just go back to there. What that's essentially saying, now that I've split my variable, my data by personality, whatever I do from now on, I'm just going to be looking at extroverts and introverts separately. So I want to look at outliers for each of those variables across extroverts and introverts, and I want to look at normality across those variables of abseiling, bowls, and meditation across introverts and extroverts. So let's do that. Let's look at analyze, descriptive statistics, explore, and I want to look, my dependent variables are abseiling, bowls, the variables I want to look at, and I want to pull them into the dependent list, those variables there. Note, I don't need to worry about personality because I have split on personality already. So let's look at statistics. I'll leave that sitting there, so it'll just give me the means, the standard deviations, the measures of central tendency and so forth, and variance. Let's look at plots. Now let's just get rid of stem and leaf, although that's a very useful plot to have. but I'll just get rid of that. And let's look at box plots with those dependents together. So I'm just going to look at abseiling across introverts and extroverts, do a box plot on that. We're going to look at bowls across introverts and extroverts and do a box plot on that, and so forth, and meditation. And I want to do normality plots across each of those variables. Let's press continue. Options, I'll leave them as the default. Press OK.
The case processing summary table shows how many cases were analysed and how many were dropped due to missing data. So in this example, we can see that there are 5 extroverts and 10 introverts in the study, and that no participants were missing from the data. The table of descriptives contains much information around central tendency, range, skewness, kurtosis, and in particular, in terms of skewness and kurtosis, these are measures of normality. So skewness, as the name suggests, indicates the extent to which there's either positive, the distribution is either positively or negatively skewed, and kurtosis relates to how peaked with thin or fat tails is the distribution. And the more that these depart from 0, the less normal the distribution is. So dividing skewness and kurtosis by the standard errors of those two skewness and kurtosis figures, or those skewness and kurtosis figures, gives the z-scores for both skewness and kurtosis. So here we're looking for seeing if those z-scores are above or below that parameter of 1.96. And what I can see here is that the range for all those groups are within the positive negative 1.96. However, warning bells are starting to sound for the extrovert group and the activity of meditation, which I'll examine in more detail in the following normality tests and outlier analyses. The Shapiro-Wilk is the standard test of normality. So both it and the Kolmogorov-Smirnov test the null hypothesis that the data come from a normal distribution. And they often lead to the same conclusion. But in the event that there is a disagreement, such as in the the extroverts who meditated, then use the Shapiro-Wilk. So if the test is not significant, so for example, if the p-value or the sig value is greater than 0.05, then the null hypothesis is retained and the normality assumption for that cell is met, and the data assumed to come from a normal distribution. If the test is significant, so in other words, the p-value or the sig value is less than 0.05, then the null hypothesis is rejected in favour of the alternative hypothesis, and the normality assumption is not met, and the data are assumed to come from a distribution that's not normal. In this case, the significance of all groups of scores for the Shapiro-Wilk statistic is non-significant. So we can conclude that the assumption of normality is not violated. So histograms, stem and leaf plots, box plots, they're always great things to do, and they give you a very good visual interpretation of what's going on. So here I'm showing you box plots, also called box and whisker plots. So here the box is the 50% of the scores, ranging from the 25th quartile up to the 75th quartile, and then you've got your whiskers. And the whiskers are the extent to which the highest and the lowest points in the distribution are that aren't outliers or extreme scores. Here you can see that for each box plot, it's roughly symmetrical for extroverts who played bowls and abseiling. But the same cannot be said for meditation, which further confirms the disagreement between the two types of normality tests that were talked about previously. So outliers and extreme scores are you can also see in the box plots, and they're indicated in the box plots by the empty or coloured circle respectively, and the star represents an extreme value. So if you wanted to confirm any of these suspected outliers, you can obtain z-scores for each of the participants' score within each cell. Now, any participant with a z-score of more than 3.29 would be an outlier, a univariate outlier. Now, in the meditation group, there is an extreme score for case 4. However, in the interests of brevity, I ran z-scores for this cell and for all other cells and found that the z-score was not above 3.29. So as a result, this extreme score has not been modified in any way, and I haven't gone into it in any more detail in this analysis. Here you can see that each box plot is roughly symmetrical for introverts and confirms the results of the normality tests that were shown previously. There don't appear to be any outliers in the introvert group.
Okay, so we've looked at normality and we've looked at outliers, and we found that there is normality in our variables for each cell, and there's also no univariate outliers. So the next step is to look at homogeneity of variance for the between subjects variable of personality, and also Morchley's test of sphericity for the repeated measures variables, and conduct our mixed ANOVA. So let's go ahead and do that. But before we do that, I always forget, if you've got your data file split, then let's click on data and go to split file, and you may have already have your personality you may have already had that. So let's take that off. Let's just go analyze all cases. Do not create groups. So what that's essentially doing is it's essentially saying, I don't want to split my file by personality anymore. What I want to do is I want to look at all my data. So press OK. Let's go back to the data. So we're going to go Analyze, General Linear Model. Let's click on Repeated Measures. Now we've got that repeated or within subject factor name called factor 1. Well, that's a pretty user-unfriendly name. So essentially our within subjects factors, they're abseiling, bowls and meditation. So to me that says activity. So let's just call it activity. Now when you look at activity, there are 3 levels for that repeated measures variable of activity. That's abseiling, bowls and meditation. So let's call it three levels there. And let's go add. So what that's saying is we've got an activity variable. It's got 3 levels. Of one of those levels is abseiling, bowls, and meditation. Let's click define. Now it's asking where those question marks are on the right hand side. It's asking us, well, given that we've identified or defined this variable called activity, tell me tell SPSS what the levels are. And those levels are abseil, bowls, and meditation. Let's pull those over. Now at this point in time, where we're at is, we're at the same spot where we were with a one-way repeated measures ANOVA. The only difference now is that we're about to tell SPSS that there's a between subjects factor of personality. You're either an introvert or you're an extrovert, you're not both. So let's grab personality and put it in the between subjects factor. Now you've got a bunch of options here, and really all we want to use are 2 of these at this present point in time. The first option we want to use are options. So let's click on options. Now we're interested, when we do a mixed ANOVA, we're interested in the main effect for personality and activity, and also an interaction effect of personality and activity. So let's grab all of those and let's display means for those. Now as soon as I park those over into the display means for, you'll see compare main effects pops up as a valid thing to tick. Let's tick that. And once we tick that, what you're going to get is 3 options. Tukey's LSD, which doesn't correct for family-wise error, so I'd recommend, it's rare that you would use that. Then you've got your Bonferroni or your Shadak. Let's use Shadak in this case because it's slightly more powerful. And let's tick Shadak. Now, we're interested in a few things here. We want to get descriptive, so let's get the mean and standard deviations. Let's get the estimates of effect size. Let's get the observed power. Because we've got a between subjects variable of personality, let's get homogeneity tests. Let's do a homogeneity test or Levine's test to test for equal variances across that between subjects variable. So let's click continue. Now, whenever we're doing a mixed ANOVA or looking at any interaction or even not, it's best to get a visual representation of what the data is doing. So let's do some plots. Let's click on plots, and here we've got the 2 factors or 2 independent variables. We've got activity, and let's park that in the horizontal axis, and the between measures variable, which is personality. And so let's park that over there, and what that'll do is give us activity for introverts as a separate line, and extroverts will be a separate line. Let's click add and go continue. Now when we press OK, we're going to run the analysis and be able to check for homogeneity of variance and sphericity, and also look for any main effects for activity or personality, and any interaction effects.